All right, welcome back. This is lecture 6. This is our first lecture on the supply side of things. Um, and this is theory of the firm. That's how we're going to refer to it in our microeconomic theory. Let me just give a little preview of what is to come, not just in this lecture, but moving forward. So we'll have today, this will be, let me just call it supply 1. So today, Wednesday, July 9th, at least that's when the video was recorded. Today is when we see supply 1. Monday, we will see supply part 2. And this is it for supply. I'm going to try and cover all of the things about just the supply side of the theory in these 2 lectures. They're going to be a little bit packed. We're going to have a bit of material to get through. But one of the reasons that we kind of just stuff all of this, I kind of just stuff all this in 2 lectures, and even my grad school lecturers will not spend so much time on supply, is because what you will see is that we set these things up in a way such that it is nearly identical how we model the firm to and the consumer. We've designed the economic models, the framework for all of this theory, such that um, they follow the same structure. Although the rules for a business, a firm, is going to be different than the rules for a person, you or me or whoever have you. Um, but we want our models to generalize nicely. And one nice consequence of this or result of this is that we can model firms in a very, very, very similar setup to the way that we model people, consumers. So today so today's lecture 6, lecture 7, 6 and 7 will cover all of supply, and then Wednesday will be properly. This is referred to as general equilibrium. This is where we'll see the supply and demand graphs together. We will bring supply and demand together. And specifically, we will be focusing on perfect competition. So we'll be staying in the perfect competition world, which is where everything works out the easiest and it's not, we see the nicest results. The results are the easiest to work with and very similar, very, very similar to what you saw in your first principles of micro class. All right. And then that following Monday is when we'll do the same thing. We'll spend another lecture on it. Call it perfect comp. Right, we had 1 and 2. And then these 2 lectures will be sufficient to bring the 2 together, at least to the point that I want you guys to be comfortable with. And then that following Wednesday will be the midterm. All right. So the midterm is going to cover the demand theory, supply theory, and then just perfect competition. All right. We're going to cover equilibrium models with only under perfect competition. So no monopolies, no monopolistic competition, none of that. It's all going to be just this more rigorous treatment of these things that we saw in principles of micro. Right. So this was 6, this was 7, this was 8, this is 9, and then we don't have a lecture 10. It's going to be the exam day, but that's how it's going to go down. So that's what we have looking ahead. All right. Today, let's focus on this one that we have today. All right. Which is just introducing the theory of the firm, starting to work with the supply side of things. All right. First, we're going to lay out just the basic things that we need to consider. This is going to be a lot of refresher from, maybe not a lot, but this is going to be a bit of a refresher from your principles of micro class when you worked on the supply side of things. And we're going to just put that to a bit more rigorous mathematical framework, kind of as we've been doing with this class. And then we're going to look more specifically at how do firms produce? How do we model production? How do we handle production? And we will see that today we will just start with looking at the short run. All right. And then in the next lecture, we will consider the long run, and we will also consider the two. How do we get from short run to long run, excuse me. And then what is the relationship between the two? All right. We're mostly going to be working from the the Landsberg book. The Perloff book is where I just borrowed some of the mathematic notation, but the intuition and a lot of the examples are going to come from Landsberg. So honestly, for when I was looking at these chapters, he this book is these chapters are a bit wordy, but the intuition is good. The intuition is good. So if you prefer words, if you like more words than equations, then Landsberg is pretty good. If you like more equations than words, then Perloff is going to be what you want. But see these are the references. This is what I'm using to guide these lectures. But as always, I'm kind of putting my own spin on it. All right, so let's begin. So up to now, we've been focused on the demand side of things. We've been working with consumers, and how do we get the demand side of the market? We saw the behavior of consumers. We saw that for the demand side of the market, we had consumers, and specifically, we saw that consumers maximize utility. All right, the utility maximization problem, or the constrained consumers problem. And what did we need to consider with that? Well, we needed to consider consumers' preferences and budget constraints. And as I said, this was the problem of utility maximization. All of these things compose the consumer's problem. What did we find? What did we learn was that in our models, we modeled that the consumer chooses, that the thing that a consumer chooses to do, whatever is optimum, is defined, is characterized by this rule that the marginal value, the marginal benefit, that the marginal benefit is equal to the marginal cost, and specifically marginal cost of consumption. All right. And the books, the textbooks, both of them, I think, at least Landsberg, refer to this as the equimarginal principle. This is honestly pretty widely applicable, not to just this models, not to just this micro theory stuff, but to real life, right? At the margin, you should be indifferent between the two. If one gives you more benefit, then go do the thing that's giving more benefit. If one costs more, don't do that thing. All right. This is the equimarginal principle. Now we're going to work with the supply side of the market. Now we're going to work with firms, the behavior of firms and businesses. And what we will see is that firms maximize profit, which is intuitive. And instead of preferences and budget constraints, firms have production strategies. Specifically, firms will have different production strategies depending on what type of market they're in, depending on what their productive capabilities are, depending on who is who are they selling to. These will all affect how a firm chooses to do business. All right. And these are some of the things that we want to capture in these economic models. And as I said, we're introducing this stuff in a way such that it's very, very similar to how we model the consumer's problem. In fact, I think you might agree with me here that the firm's problem is even more realistic because the consumer's problem, we assume that the consumer is just doing this mental calculus every time to make the decision, which, you know, we give thought to our decisions, but do we consider calculus-esque computations to make every decision? Debatable. But a business, a firm does care about being very precise about how much money is coming in and how much money is going out. We don't want to be in the red. All right. If you're a business owner, if you're burning cash, this is not good. So chances are you are going to be precise there. So what I'm getting at here is maybe this stuff is even more believable. Right. That is, we're going to be looking at the firm's problem of profit maximization. In the same way, they still abide by the exact same optimal rule that the marginal benefit with the marginal value is equal to some marginal cost. Except now, instead of cost of consumption, it's cost of production. And this is just another version of the equimarginal principle, one of these guiding things in economic models. So what does this look like? With that being said, this is the goal. This is what we're trying to do. We're going to start with in this lecture. So what does this actually look like? Well, first, we need to get some ground rules clear. We need to get some very fundamental things clear. We need to be clear about costs and benefits. All right. Benefits for a firm is revenue. All right, revenue. For the consumer, your benefit was your utility. How much did enjoyment or pleasure did you get out of a decision? But for a firm, the benefit is the revenue that comes in. All right. And if there's one of the main things that you guys should absolutely get right every time, if you didn't have this locked down in principles of micro, you're going to have this locked down now, is that how do we calculate revenue? All right. And what I really, really need to emphasize, because this does get misconstrued. In principles, I saw this a lot. So now we're in a more grown-up class. We're taking Econ 300 rather than 200. With being an intermediate micro, we should know this. But just to be crystal clear, we should know that revenue does not equal profit. All right. Profit is after we subtract out costs. Revenue is just the pure gross amount of money coming in. All right. We need to be clear. We need to be absolutely clear that this is a gross amount, and you need to know the difference between these two if you're going to work in the business world at all, where this is a more net amount. All right. Net meaning net of costs, in excess of costs. All right. So nobody in this class should get this wrong. When I ask you, how do you calculate revenue? How do you calculate revenue? It's very simple. It honestly could not be more simple. Revenue is simply the price of the thing you sell times how many things you sell. All right. That is it. That is it for revenue. If we were to put this in math, all right, it's simply revenue is a function of quantity, and it's just price times quantity. All right. Straight up easy. All right. Why is this just a function of Q and not P? Take a sec, see if you know the answer. The answer is that we're working in perfect competition. All right. I won't I won't diverge too much to this, but right now, all I want to point out is that this is a function of Q only. Why is that? Because this is perfect competition. And this implies that firms are price takers. They don't make their price. They're just at the whim of whatever the consumers, whatever the people that you're selling to, they're willing to buy. All right. So revenue is quite simply just price times quantity. All right. Now, remember, we care a lot about this notion of at the margin, marginal value, all right, or marginal benefit. Here, marginal value is marginal revenue. All right. And so mathematically, it's just the derivative of the revenue function with respect to quantity. All right. The idea is what is my marginal revenue is how much more money, what is the money that comes in as a result of producing one more unit. All right. Quite literally marginal revenue. So we represent it in this way. And just to be concrete, this should be an example that is familiar from your principles of microeconomics class. All right. But just to refresh our memory, just to jog our memory, let's consider a super simple example. All right. Suppose that we're looking at a pizza shop and they face a horizontal demand curve. So they sell pizza for $7 a slice. And then you're being asked to calculate total revenue and marginal revenue produced. All right. Well, and then I want you to fill in this table. Take a few seconds and you should be able to fill this in. pause the video here. All right. And then what you should have found was that total revenue. Well, if they sell one slice, they're getting $7. If they sell two, 14, three is 21, four is 28. All right. So revenue is scaling linearly. And then marginal revenue, what do we notice? Well, marginal revenue is how much revenue comes in from selling that one extra unit. All right. So from 0 to 1, how much more money came in? $7. From 1 to 2 units, how much more money came in? $7. Then from 2 to 3, you guessed it, $7. All right. One thing that we notice is that, and why did I highlight this? Is that a horizontal demand curve, this implies constant marginal revenue. All right. As opposed to if we had remember horizontal demand curve, this is QD, and you're gonna have some upward slope in supply curve. We'll have a QS. All right. So this is if we have how did I phrase it here? Yeah, I just called it a horizontal demand curve. All right. What do you remember about a horizontal demand curve from your principles of economics class? Principles of micro, that is. What would make a demand curve perfectly horizontal? Well, if you recall, if you search deep in your memory, you remember that this means that demand is perfectly elastic. That's why I should not label these as Qs, but rather I should just label it as demand and supply. All right. So we remember from principles of micro that if demand is perfectly elastic, then they are staying at this price. If you raise your price even a little bit at all, they're gonna go buy from somebody else. All right. So horizontal demand curve means that demand for this good is perfectly elastic. All right. And this also means that marginal revenue is a constant, is a fixed number. And what is it? It's simply the price that you sell for. Not the perfect grammatical, but whatever. Not perfect grammar, but whatever. As opposed to a downward sloping demand curve, all right, where we're used to seeing something like this. Demand is downward sloping, and supply is upward sloping. Well, a downward sloping demand curve implies that we get decreasing marginal revenue. All right. Of course, this is going to imply that demand is not perfectly elastic. I didn't go into this. I kind of skipped a little bit of this, but the idea is that when we're dealing with the downward sloping demand curve, the elasticity of demand, price elasticity of demand, that is, will change depending on the upper portion, the middle portion, or the lower portion. And so, but all I want to say is we would just group all of that into saying that demand is not perfectly elastic. All right. So that should be generally a refresher from what we saw or from what you saw in your principles of micro class. All right. And I use the tables for now just to keep it easy to introduce these ideas. We will use functions later. For now, we just need to introduce these ideas. All right. So that's the benefit side of things. Remember, we're always trying to match marginal benefit to marginal cost. We want these things to be equal at the margin. But what about the cost side of things? Well, these are more simple, right? Or I shouldn't say simple, because that's not quite true. These are more intuitive, right? There's a cost of doing business. There's a cost in getting whatever place you're doing business. You know, if you have a food truck, you got to rent the food truck. You have a storefront, you got to pay rent there. You have a factory, you got to pay for the factory, all right? Or you got to pay for your workers, all right? So there are costs of doing business. What you should have seen in your principles of micro class was that we decompose costs, we lump them into two groups. You have your fixed cost and your variable cost. All right. Your fixed costs are going to be things that, let me write this down actually. Your fixed cost, which we will usually just denote with F, right? Fixed cost is things, or I should say, costs that do not depend on quantity. All right. Costs that do not depend on quantity. This is usually like your rent, the rent for the building. Doesn't matter if you're only selling one thing or 10,000 things, that rent's going to stay the same. All right, that rent is going to stay the same. But you also have what are variable costs. And these are things that do depend on the quantity of stuff that you're selling. So to be explicit, costs that do depend on quantity, quantity produced, rather. For example, I like the example of like a bakery. Well, if you're selling one cake, you only need ingredients for one cake. But if you're selling 100 cakes, well, then you're going to need a lot more flour, a lot more sugar, a lot more eggs. So ingredients. All right. Whereas you're paying the same rent, whether the bakery is super busy or super dead, that rent at the end of the month is still the same. But if your bakery is super busy, you're going to pay a lot more cost for flour, eggs, sugar, whatever. And if you're not that busy, well, then you're probably not paying too many of those costs. But business is not that good, so maybe that's not good either. All right. So we should remember this from your principles of micro class that we have total fixed costs and total variable cost, and that's what comprises total cost. In shorthand notation, to put this to a mathematical model, we're just going to refer to this as this is our cost function. All right, the cost function, and we just refer to it as this. All right, because variable cost does depend on quantity, so that's a function of Q, but fixed costs do not. Hence, the marginal value is the derivative of the cost function. All right, I'm sorry, excuse me, marginal cost, not marginal value. Your marginal, I will correct this in notes. I guess marginal value is fine, but it's a marginal cost. All right, the marginal cost. I guess I just didn't want to repeat the marginal cost is the marginal cost. I didn't want to say that twice. But the number itself, the value of the cost is just the marginal cost. It's just a derivative of the cost function. And so I'm going to just say this out loud now, and we will make a note of it later. Um, if I'm taking the derivative of the cost function, does fixed cost affect our marginal cost? Write that in your notes what your answer is, and we'll consider that later. Right? So let's concretize this. Let's formalize this with another simple example. So suppose that same pizza shop from earlier faces the following cost table. And I want you guys to calculate total cost and marginal cost of each unit. All right. So pause the video now and fill in this chart right here, if you are able. I'll give us a few seconds to do that. All right. So what you should have found was that, well, your total cost, remember, it's just your fixed plus your variable equals your total cost. And so your total cost should have been 16 here, should have been 22 here, should have been 26 here, 28, and then this should have been, yeah, this is good, and then 31. All right. And then what is your marginal cost? Well, going from, we can, usually you kind of ignore this one, but it's all right. Marginal cost, I will go ahead and fill this one. So from 0 to 1 units, um, let me ignore this one for now. So you ignore the first cell of marginal cost. Then what's the marginal cost of the second unit? Well, going from 1 to 2, our total cost goes from 16 to 22. Thus, the marginal cost here is 6. And then we do the same thing. What about from the second to the third unit? Our cost increases from 22 to 26. So we have a marginal cost of 4. And then again, from the third to the fourth unit, the marginal cost of the fourth unit is 2. There we go. And then for the last unit, we go from 28 to 21. I'm sorry, 31. And so we get a marginal cost of 3. So we see that from here to here, we have diminishing marginal cost. And then, I don't know where those dots come from. From here to here, we have diminishing marginal cost. And then we have an increasing marginal cost. All right. There's an inflection point. Keep this in mind that for a while, marginal costs come down, but then there's an inflection point where they come back up. All right. This idea will be important and it will be referred back to. So what do we notice or what should we take note of? Well, first, that what I pointed out just a few seconds ago, or maybe a minute or two ago, is that a change in fixed costs, does not affect marginal cost. All right. And why is that? Because if this is our cost function and we define marginal cost as the derivative of the cost function, well, when we take the derivative of this is a constant, and so derivative of this is 0. So whether this is 1, 10, 1,000, or a million, we're looking at marginal cost, it doesn't affect our marginal cost. We're always paying that fixed cost. So a change in fixed cost does not affect marginal cost. Meanwhile, a change in variable cost has an impact, affects the marginal cost. Does affect marginal costs. All right. And then we saw that MC decreases up to a point. Then begins to increase. All right. This type of stuff should be familiar from your principles of micro class, wherever you took it. But we're just, one, we're refreshing it, and two, we're trying to formalize it a little bit. All right. But these are the basics. That's the basics of benefits for the firm is revenue. And the cost for the firm are their cost, all right, the actual cost of doing business. So when we bring these two things together, when we're considering firms in the marketplace, of course, now we need to define what is profit, all right? And your profit is your total revenue minus your total cost. Revenue is the money coming in, the costs are the money coming out. All right. And the difference between the two, that spread right there, is your profit level. All right. So this, nobody, absolutely nobody should get this wrong. If anybody tells me that if I ask you, how do you define profit? And you give me revenue, price times quantity, that's an immediate zero. All right. We are too grown for this. All right. I say that kiddingly, but I do want you guys to get this solid. All right. So mathematically, we define profit as the revenue function minus the cost function. All right. And we call this in econ, we like to refer to profit with this pi symbol. All right. That's the variable we reserve for profit. So with this in mind, how do we know what quantity of output will maximize profit? Well, you can go about this in two ways. You can go about this in two ways. One, you could just simply calculate profit at each unit. You could simply do exactly this, total revenue minus total costs, and calculate profit at each unit. And just see at what number of units is profit maximized. Gives us the highest profit level. Alternatively, you could just find where MR equals MC, what I will often refer to as the golden rule. If there is anything at all that you take away from not just this econ class, but any econ class at all, you should know that the golden rule is where the marginal revenue is equal to the marginal cost. This is true for anybody's problem at all in economics, whether it's the firm or it's the consumer, all right, whether it's a business or a person, doesn't matter. The optimal point is where the benefit is equal to the cost. The marginal benefit is equal to the marginal cost. So I refer to this as the golden rule. There's nothing else you remember from this class, nothing else you take away from this class, except for one thing. It should be this thing. All right. So why do I bother presenting two methods? Well, let's see. Consider this example. All right. So suppose a farmer is growing wheat and this wheat sells for 10 bucks per bushel. All right. And we're going to make some simplifying assumptions. Suppose that the cost of farming is constant for or at $240 per acre of land. And then let's also assume that there's no fixed cost. All right. So suppose this guy owns the land. He doesn't have to pay rent to anybody and just ignore the taxes right now. All right. Maybe the IRS might not like this example, but it's just fine for us. Right. So my question to you is, what is the optimal number of acres? Which number should we choose if we use method one? And then again, what if we use method two? Are these answers the same or are they different? Go ahead, pause this video now and try it out for yourself and see what do we find. All right. So what you should have found is that, well, and the way I conveniently organized this table for us is that these first two, these right here, this is method one. Method one is right here. All right. Because method one was looking at TR and TC. Meanwhile, method two is looking at MR and MC. And so that is this column, or these two columns rather. All right. And then how do we calculate profit? Well, you actually have to use method one to calculate profit. So to calculate profit, it's TR minus TC. And then you should have found that your profit column looks like this. That for the first unit of land, the first acre of land that we employ, we get a profit of 160. The second one gives us a profit of 280. The third gives us a profit of 360. The fourth yields a profit of 400. And the fifth also yields a profit of 400. So notice the tie. All right, notice the tie. And then that sixth acre of land yields only a profit of 360. All right, so clearly the highest profit that we can get here is 400. All right. So let's make a note. Method one says that 4 or 5 acres is optimal. On the other hand, remember method two is comparing MR. We want to see where MR is equal to MC. Well, we conveniently have the MR and the MC columns here. We see where are they equal? Where are they equal? Not here, not here, not here, not at this fourth unit, but at the fifth unit only. So at the fifth unit only, MR is equal to MC. And method two suggests that we should employ 5 acres, that 5 acres is optimal. All right. So method one gives us a tie. Method two gives us a singular answer. All right. So which one is better? Well, we don't want ties. All right. We want a rule that just gives us a single answer. Now, if you're an actual business owner or somebody that's making business decisions, then there might be a little bit more nuance that goes into this answer. But generally, one reason that I think is very intuitive, why do we like this? Well, method two told us to go with the higher one, right? And when I say higher, I mean that this is using um, more units of land. All right, we use more acreage than method one says 4 or 5 is. Meanwhile, method two says, oh, 5 is your number. Right? Some intuition for this is why do we like method two? One of the reasons we like method two is that if I use 5 acres, then I'm probably selling more stuff. All right. Although the profit is the same, I'm selling more stuff, more of my stuff, more of my items are out on the market. So this means I'm getting market share. If I know that I could go with 4 or 5, that they both maximize profit, let me go ahead and employ 5 units of land because I'm going to be selling more of my stuff. Even if the profit is the exact same, more of my stuff is being sold on the market and I'm capturing market share. So although the market share doesn't immediately enter our profit function, this is valuable. If you're a business owner or if you're making business decisions, not even the owner, but just making business decisions, you want market share. You want more of your stuff to be in people's hands. And so that's just one reason why method two is preferred. So another reason why method two is preferred, we will see. Let's consider another example. All right. So why use method two? Consider another example, but now suppose that there is a fixed cost. All right. Now suppose that there is a fixed cost of 250 bucks. How does this affect the farmer's decision making? Well, what you're going to do, you can pause here, recalculate profit. Now taking into account this fixed cost. Take a few seconds and calculate profit. And what you should have found is what I have for you on the board, on the screen. All right, so now once we add in or take into account a fixed cost, this changes our profit calculation. All right, this changes our profit calculation. And what do we have to do? Uh, my point here is not to make you guys do simple adding and subtracting. In this case, it's just subtracting. But the idea, the more so idea, is that we included the fixed cost. We had to recalculate profit. We had to do more work. Meanwhile, what did we say earlier? Does a fixed cost change our marginal cost? No. So if I'm going with method one, then I have to redo this profit column. Maybe I'm doing it in Excel, but I still have to make an extra column. Right. On the other hand, if I'm doing method two, I'm simply looking at MR and MC, And I'm noticing, well, I can just look at the columns that I have right here, and I immediately know that this is where I want to be. The MR is equal to MC when I'm using 5 acres of land. And I know that's giving me the highest profit there. And I get a simple one answer for what is optimal. Meanwhile, method one, if I'm just calculating total profit, I have to recalculate profit. That'll take more work. And then I will still end up with a tie. And so that is not good. All right. It's just another reason why we prefer method two. All right. So that is another reason why we prefer method two. And I just want to add these notes here. Um, that with method one, must recalculate profit at each step. Must recalculate profit. And so that's not desirable. And, or meanwhile, in method two, fixed costs do not affect marginal revenue or marginal cost. Fixed costs do not affect MR or MC. Thus, method two, we might say, is more efficient. And remember, so the fixed cost does not affect, changing a fixed cost does not affect your MC, but a variable cost will, right? All right. Variable cost will affect MC. All right. Great. So that's kind of a recap of what you should have learned in Principles of Micro. And if you didn't learn it in your last class, well, now you know it. All right. So now let's bring it up. Now let's do better. All right. Let's take a deeper dive into how we model uh, the how do we model with economic theory what firms do. All right. So first, we're going to focus on production. All right. Production is simply combining inputs to create an output. All right. Quite simple. Couldn't be more clear cut than that. Mathematically, we use a production function to describe this relationship. All right. In general, the production function describes quantity as a function of your inputs. So let me make a note here that here the production function gives the relation between output and inputs. But specifically, I just wanted to note here, and for this class, we're only going to be focusing on labor and capital. All right. K in econ refers to capital. You can think of this as the machines that you rent or anything that must be rented for you to do your business. Meanwhile, L is labor. All right. How many workers must I hire or how many hours must I pay them for? For simplicity, we just assume that these are the only two inputs of production for now. All right. So here, focus only on labor, L, and capital, K. YK for capital. I believe it's a historical thing. We have the well-known Das Kapital, actually actually written by Karl Marx, actually the guy that is accredited somewhat incorrectly. I shouldn't get into this tangent, but let me just say that the K comes from Karl Marx's um, piece of work, Das Kapital. So Marx was an economist himself, or at least in his day. We didn't have computers. We couldn't do all of this analysis that we have the power to do today. But Marx was an economist himself, and all I'm going to say about him and about his work about Marxism is that what Marxism is, what it actually was, and what he was actually talking about back in the day is not what is referred to in like pop culture or the media these days. All right. Marx actually had different ideas than what gets proposed or reported to be what socialism is. All right. This is not the time nor place to go into these things, but just a bit of economic trivia. Right. Marx thought a little bit differently than what you might have heard Marxism is. And if you find that interesting, I encourage you to go read on what exactly was in Das Kapital. All right. It's a bit more mathematical and it's not what you would expect. All right. He was not a dumb guy. He and ever he wasn't proposing that everybody just get free lunch. All right. I will leave it at that. All right. Nonetheless, here we're only focusing on labor and capital. All right. But there are others. But there are, of course, other inputs to production. All right. There are other inputs. Some of those going to be land, raw materials, raw materials. That's fine, etc. All right. But for simplicity, we're just going to focus on labor and capital. All right. And so the quantity of output that you produce is going to depend in some way on how much capital you're using and how much labor you're using. For example, consider this production function. All right. Cobb-Douglas production function. All right. Well, if we allowed both of these things to vary, then all of these cells in this table refer to the quantities. Meanwhile, right here refers to how much labor am I using, and right here refers to how much capital am I using. And these are just different outputs of the function given different discrete values for units of labor and capital. The idea, why am I showing you this, is that in the short run, and I have it here, in the short run, one or more inputs are fixed. So we usually, I think I have this later on the slide, but the idea is like, we usually like to, if I have to take one of these two, if I have to take a stance and say, all right, in the short run, you can only change one of these things. Well, typically it's going to be capital is fixed. Because remember, I like to say like the rent is your capital, is your input of capital. Right? You have to rent a place to do business. In the short term, you can't get out of your lease agreement, right? So you can't change the size of your building, or you can't break your lease, right? At least not without penalties, right? So usually capital is fixed, and then we allow labor to vary. Intuitively, because you can always hire. It's much, much quicker. You can do this much, much more quickly and fluidly. You can hire more workers or you can fire more workers, right? So typically in the short run, we assume that capital is fixed and the labor should vary because we can cut guys or we can hire more people. So you'd say, okay, suppose I only have one factory, then, and I'm just choosing how much labor do I want to use? This, this is the short run. Meanwhile, if I were to consider all of these things, not just leaving capital fixed, but allowing us to consider different combinations of labor and capital, then this is the long run. That's one of the key distinguishing differences between short run and long run in these economic models. Right? Is that in the short run, one or more inputs, excuse me, are fixed, whereas in the long run, everything is variable. All inputs are variable, so nothing is fixed. And I just want to say is like, for example, i.e., a short run would tell us that Q is equal to 3KL, and then they would say, suppose K is fixed to be 3, or in our example I did above, it's fixed to be 1. Whereas in the long run, Q is 3KL, and that's it. There's nothing fixed. It's just 3KL, and I can change K and L. Meanwhile, in the short run, we just leave K as fixed. So we're going to start with just the short run. All right, we're going to just start looking just at short run because it's easier to consider things when there's only one moving part. All right. So let's look at production in the short run. One moment. All right. Had a bit of technical difficulties, but it's okay. Um, okay. Yeah, I had a bit of technical difficulties. It made me purchase the pro version of GoodNotes 6. GoodNotes 5, I shouldn't have upgraded, but whatever. So I will have to add those little annotations back. But all right, back to the topic at hand. Let's look more closely at production in the short run. All right. So in the short run, we often assume, right? Production in the short run, we often assume is what I just said earlier, is that capital is fixed, whereas labor is variable. All right. So let's focus on this. If capital is fixed in the short run, then let's focus on labor for now. All right. If we're focusing on labor, then we need some measurements of productivity. All right. What are the consultants that come into the corporation come and do? They come and they analyze productivity. All right. They're gonna analyze what is the total product of labor, the marginal product of labor, and the average product of labor. Let's define these things. All right. What do I mean when I say these things? Well, total product is simply just your total quantity of output. So how much output is being produced with so many units of labor. So total product of labor is simply the quantity Q that is produced. The marginal product of labor is how much more stuff is produced when hiring one extra worker, right? So we might say that that is the change in quantity with respect to the change in labor. Or we could say dq dl with calculus. Lastly, the average product for labor is just the average amount of production per worker. So when I say that, that's going to be Q divided by L. Not a change in Q, but just of all of the quantity of output that we're producing divided by the number of laborers that we're employing. And that's our average product per laborer. This is exactly the same thing as total product of labor divided by L. All right. So these are our three measurements of productivity, at least in the context of labor. So just to get us comfortable with this, let's fill in this following labor productivity table. And not only do I want us to fill in these numbers, because I know this seems a bit simple, but I also want to note at what quantity of labor do we see diminishing returns? All right, diminishing returns to labor. Take a few seconds, fill this in, pause the video, and then we'll resume. All right, and then what you should have found, or how we should have found it, is that remember marginal product is how much more is gained, how much of this total, how much is added when I go from this step to this step. All right, so from 0 to 1, that marginal product was 5. From 1 to 2, that marginal product, well, we went from 5 to 12, so that marginal product was 7. And then so on and so forth. From 2 units of labor to 3 units of labor, our total product changed by, we went from 12 to 21. And so this was a marginal product of 9. And then we see from 21 to 28, that changed by 7. From 28 to 33, this changed by 5. From 33 to 36, changed by 3. And then finally, this changed by 1. So at what quantity do we see diminishing returns? What I mean by that is that we notice that, let me put a little divisor, here to here, that here we have increasing returns to labor. Meanwhile, down here, we have decreasing returns to labor. And this is kind of intuitive because if you don't have that many workers to start with, like if you're a small business or it's literally just you an operation, well, once you add that first person, you're going to be able to do a lot more than what just one person was going to do. All right. But take the other extreme, consider like a corporation, a big business. They already employ like 1,000 workers. Then the worker that they just hired, the number 1,001, they're not gonna change the product, the output all that much. I mean, it must be if they hire another worker, then ideally somebody's doing some cost benefit analysis and saying that, okay, we can afford to hire one more worker and it will be in our best interest to hire one more worker because it's going to improve the business. But they don't always increase output as much as those first guys did, as much those founders did. All right, founders bring a lot of value because you start with a small team and then you expand. Once we have a very large team, then those next people that we hire, maybe they're not having as big as an impact as when we went from 0 to 1 extra person. Maybe when we go from 6 to 7, the impact is not so large. All right. And then what is our average product of labor? Remember that average product of labor is simply your total product divided by your number of laborers. So mathematically, this maps to TP divided by your number of L. All right, so 5 divided by 1, clearly this is going to be 5. And then 12 divided by 2, it's going to be 6. 21 by 7 is going to be 3. 28 by 4 is going to be 7. And then I'm going to just do the fractions for this one. We have 33 over 5. And then we have 36 over 6 is just 6. Then we have 37 over 7. All right. And so we notice also that there's an inflection point for average product as well. But I will speak more on that in just a few. All right, in just a few. So we make note that total product is always increasing. Duh. Right? If we have more workers, then of course we're going to be able to do more stuff. This is not going to make us less productive. Right? Meanwhile, marginal product, first increases, then decreases. All right. And then I just want to say that first increases, then decreases, that there is a switching point. All right. There's some switching point at which an additional worker is not the marginal product from the next worker is not as great as the one before him or her. So some intuition for this is that up to the switch point or inflection point, if you prefer, up to the switch point, workers can further specialize. Workers can further specialize, meaning that when we're early stage of business, then we have a small team. So every new person that we add, they're probably going to be responsible for a whole different thing. Like if I'm a small team, then I'm only going to have one accounting guy doing the accounting. I'm only going to have one marketing girl do the marketing stuff. I'm only going to have one legal girl doing all my legal stuff. So they can specialize because we're a small team. Um, at the switch point, some intuition is that the fixed amount of capital runs out. The fixed amount of capital runs out. And what is meant by this? That's simply saying that since capital is remaining fixed, we can get increasing returns up into some inflection point. Um, and then at that point, given that we've fixed capital, we can no longer get increasing returns. Right? What is meant by this? I think you will see this phrase in your career or at least your studies that we see a crowding out effect. And this is when the law of diminishing returns kicks in. All right. And this is one of the places where econ very much parallels real life. All right. You can't go and keep doing something forever and ever and ever. All right. It will get to a point to where even something that is good for you, there can be too much of it. All right. And the returns will be diminishing up until the point where it no longer brings you any additional benefit. Right? A little philosophical, but that's how the science started. So, all right. So let's continue. So as I've written here, that these tables that we're working with, well, this was principle stuff. All right. This was principles of micro stuff. We can do better. All right. So let's see what this stuff looks like graphically to illustrate some of the more finer nuanced points that I want to show you guys. All right. So if I were to plot the points from that example that we just did, if I were to plot those points, where the y-axis is quantity and the x-axis is labor, and that's how all of the graphs will be in these next upcoming sections. Well, if I were to plot the total product, it would look something like this. All right. We see roughly it increase. I mean, it's always increasing. It's just the amount of increase at first is quite large, and then it tapers off. All right. And that's that law of diminishing returns. If instead we were to plot the marginal product or the average and the average product, then what we'd see, this is the NPO. We see that we have increasing marginal product up to this inflection point, and then we see the diminishing marginal product. Similarly, we see that the average product, we also saw this in the table, that the average product per worker goes up, 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 and then starts to reduce or diminish as well. And we do notice that the marginal product and the average product lines cross. And that's no coincidence. That's no coincidence. But to see this more clearly, let's instead consider a smooth production function. All right. So if instead this is when I'm doing just units of like 1, 2, 3, 4, like whole numbers, we refer to those as discrete counting. And so we get a discrete looking graph with just points and that we've drawn this line through. But if instead we were to actually plot the function, then we would get a smooth curve. What I've marked here, remember this is quantity and this is labor. What I've marked here, this is the inflection point. This is the point at which the marginal product of labor starts to decrease. So for the total productivity curve, I have that the derivative switches, or sorry, let me back it up before. So for this total productivity curve, notice. The whole time, remember, this is an increasing function, so the derivative is always positive. But we see that at the inflection point, we see that our rate of change of the rate of change, remember, our derivative is increasing. If we had a constant derivative, then we'd get a straight line. But since the derivative is increasing, we get this this convex behavior. And so we see that the derivative itself is increasing. Before L star, the derivative itself is increasing. And that's mathematically, that means the second derivative is positive. After L star, f of x is decreasing. Sorry, f prime of x is decreasing. And mathematically, we know that that means that the second derivative is negative. And this happens where the inflection point occurs at L star. Right. Now let's relate this. How do we relate total productivity to our average product of labor, and how do we relate it to our marginal product of labor? Well, these are what I'm about to show you on the next page. It's the exact same graph. All right, this is the exact same graph. All right, for average product of labor, we remember that this is simply quantity divided by the number of labor, which is identically your total product divided by your units of labor. And what is neat, a nice geometric interpretation of this, is that we start the curve here. Your average product of labor is simply the slope. Let me write this down. The average product of labor, a nice, neat geometric result, is that at any given value of L. So here I've chosen L naught or L star. I'm calling these things, these are the same things in my words. At any given value of L, the average product of labor is equal to the slope of the line formed from the origin to the function, to the output. So what I mean by that is that, and I say origin, I mean where the curve starts, where the actual production function starts. So at L0, I take a point here and I find a point here and I calculate what is the slope between those 2 points. That slope is the average product of labor. So the average product of labor is the slope of the line formed from the origin to the y value, or to the value of the function, to the quantity, which is a function of L. That is rise over run is equal to Q L over L, right? Because this is L, and then whatever point this is, the y value is going to be Q, which is a function of L. Thus, this is simply your quantity over L, which is the very definition of average product of labor. So if you like math, then that was maybe pretty neat. And if you don't like math, then that was a little extra. Maybe it was pointless for you. But it's one of these things that we like about micro theory is that it's not obvious, not so obvious right now, but I'm trying to make it apparent to you guys, is that these little nuances with the graphs and the like very small details of like slopes and whether something is a linear line, a linear function, or a nonlinear function, means different things. So if you like this mathematical econ stuff, then those things, those little features of the models are pretty important. On the other hand, how do we relate total productivity to marginal product of labor, or total product to marginal product? Well, this one is way easier, right? The marginal product of labor is quite simply the change in quantity with respect to change in labor, or we might say dq as a function of L with respect to L. It's just the slope of the instantaneous rate of change. All right, it's just a derivative. It's just the slope at that very point. So here you have a nice slope like this. That's the MPL at L0. Here we have a flatter slope. Here we have a steep slope. All right, much easier to understand that marginal product of labor is just the slope of the total product curve. MPL is just the slope of the total product curve at that instant. That instant slash value of L. The instantaneous rate of change, or quite simply the derivative, right? So to summarize what we just said, average product of labor is your total output divided by your total amount of labor. And it's the slope of a ray that connects the origin to any value of L. All right, I should say Q of L. Meanwhile, the marginal product of labor is the change in output that occurs with respect to a change in labor. And that's just the slope of the the production function, the total product. What's the relationship between the two? Here is a key point that I want to point out. Let's go back here, here. Remember, I made a note that they do cross, all right? That the NPL and the APL, these two curves, the marginal product of labor and the average product of labor, they do cross. At what point, what do you notice about the point where they cross? This is when average product of labor is the highest, all right? To be clear, let's look. Remember, this is 4. So they cross at 4 from our table. We see that at 4, average product of labor is 7. And since we're using discrete things, then we get this tie. But if we're using smooth functions, as I have here, we see that the actual maximum for the average product function, the maximum occurs at the point at the point at which they cross. So what's the relationship between the two? Is that the two curves, uh, MPL and APL, intersect when average product is at its max. So that is how those two connect. So we connected total product to marginal product, total product to average product, and then we just connected average product to marginal product. So we got the whole triangle going, right? And as I just said, the average product is at its maximum when the two curves cross. But what about before? What about not at the point at which they cross, but what about before that? Well, before they cross, we see that if this is marginal product and this is average product, well, before they cross, we see that marginal product is greater than its average product. So before they cross, what do we notice? When marginal product is greater than average product, this is before they cross, we notice that average product, that curve is increasing. Increasing. All right. What does this mean? This means that the marginal gains from an additional labor unit are greater than the current average output. So the marginal gains from an additional labor unit, the marginal gains from an additional labor unit are greater than the current average output. All right. That's quite literally what uh what this is saying, but in English. But isn't math nice for that? All of this long sentence we can explain or we can convey um with a simple inequality. Meanwhile, after the intersection point, what do we notice? After the intersection point, NPL is now lower than APL, right? Over here, NPL is at this Y value. Meanwhile, APL is at that Y value. So when NPL is less than APL, Now we see that the slope of the average product curve is negative. All right. And PL is decreasing. All right. Now APL is decreasing, whereas before the intersection, they were increasing. And another way to interpret this is that the average output, the average output per worker at that moment is greater than the value that one more unit of labor would bring. So the average output per worker at that moment is greater than is greater than the value that one more unit of labor would bring. All right. So yeah, at the inflection point is where we want to stop. Right. Sorry, it's not where we want to stop. It's not where we want to stop. We want to stop at L star because that's where our marginal revenue equals marginal cost. That's when we get this inflection point. Sorry, back it up. Erase what I just said. Um, all I want us to have clear is these relationships right here on the screen. All right. And let's see. I think there was a lot to get through, and I'm kind of rushing through a bit to make sure that we cover everything. So I'm going to cut this lecture here. What we will see next time. So what we just discussed was production in the short run. Next, we will talk about cost, cost in the short run. Then we will talk about production and costs in the long run. And then we will talk about what is the link? How do we get from short run to long run? All right, what is the link there? And that will wrap up the supply side. But all of this, that will be next time for if this is lecture 6, then that will be on lecture 7. All right. But that's all I want to talk about today. Um, and just so that this video doesn't go on for too long. All right. As always, let me know if you have any questions. Otherwise, I'll see you guys next time.